Let's look at this problem. Consider the vectors in the following diagram and find vector r is a plus b plus c, vector s is a minus b plus c, and vector t is negative a plus b plus c. So notice that I didn't use the vector notation for r, a, b, and c. I just made them bold. Bold letters mean that we're actually dealing with vectors. So if I look at the diagram over here, I see that vector A is 4 units and it makes an angle of 30 degrees with respect to the x-axis. Vector B has a magnitude of 3 units and it makes an angle of 60 degrees with respect to the y-axis. And vector C is 5 units and it makes an angle of 75 degrees with respect to the negative x-axis. So let's start solving this. So here we have to be really organized. There's lots of little bits of information in this problem, so being organized is really, really important. So the knowns are our 3 vectors. And to save space here, what I'm going to do is actually start solving a little bit within my section allotted here for knowns. So I'm going to make a table with x components and y components, and then I'll have vector A, and I'll have vector B, and then I'll have vector C. So then I can solve for the x and y components. So let's look again at, let's look at vector A for now. So we know that vector A is 4 units and it makes an angle of 30 degrees with respect to the horizontal, to the x-axis. So to find the x and y component, I know that the x component is along the x-axis, the y component is along the y-axis. So to find the components, I have to draw the projections of vector A onto the x-axis and onto the y-axis. So this will be my a sub x, and this will be my a sub y. And I notice that a sub x is adjacent to the 30-degree angle, so adjacent goes with cosine. So I'm going to write here a sub x is a cosine, and the name of the angle is alpha. Once I know that the x component is a cosine alpha, I will know that the y component is a sine alpha. And here I'm not going to write a, b, and c in absolute value. When I just write letter without a vector symbol over it, like I did right here or there, what I mean is that I'm using the magnitudes to compute this these ax and ay. Then I have to find the x and y components of vector b. So I'm going to project vector b onto the x-axis, and this will be bx. I'm not going to write that in because I'm going to make a mess with all of the different letters in there. And then this will be my by, so I can do by here. I have space for it. I don't have space for bx over there. And now I'm going to look at the fact that the component that is adjacent to the angle is actually my by. So by is adjacent to the angle. So by will go with a cosine, meaning that then bx will go with a sine. So the x component then is b sine angle beta. And the y component, I noticed that it is in the negative y direction, so it picked up a negative sign here. So I'm going to call this negative b cosine beta. Next, I will look at my vector c and notice that vector c makes an angle with respect to the x-axis. So when I project this vector onto the x-axis, onto the negative x-axis really, the x component will be adjacent to the angle. Adjacent means cosine. So I'm going to have here, for the x direction, negative c, negative because it is going in the negative x direction. So this is my cx, sorry. And then cy will be positive because it's going up in the positive y direction. So again, cy is negative and it's adjacent to angle gamma, so it's negative c cosine gamma. Then the y component for c is positive c sine gamma. So those are our knowns. I didn't plug in any of the numbers yet. Let's look now at our unknowns. And our unknowns are basically everything that we have here. So in part A, I want vector r. I'm not going to copy it over. I want vector s, and I want vector t. Again, I'm trying to save space here because there's lots to write down and I don't have much space on this page. And the diagram was already drawn for us. So had it not been drawn for us, we would have had to draw something here, but we already have everything we need in the diagram that was given to us. So the next thing I'm going to have to do is find numerical values for ax, ay, bx, by, and cx, cy. So when I plug in numbers, I end up with, I'm going to redraw this table here. So I have A, B, and C. So when I plug in the numbers, I end up with AX as 3.46 and AY as 2.00. B will be 2.6 and negative 1.5, and C is negative 1.29 and 4.83. Let's make a little bit of room here. Get rid of this line. And now I'm going to have to start solving for my vectors r, s, and t. So remember that you have to always add things only in the x direction or only in the y direction. So I'm going to find the x and y components of vector r. So rx then is going to be a sub x plus b sub x plus c sub x, because that's what the equation for vector r is. It's a plus b plus c. So the x component is going to have the same relationship. It's going to be a sub x plus b sub x plus c sub x. And then when I enter the values here, a sub x is going to be positive 3.46. B sub x is positive 2.60. And c sub x is actually negative 1.29. So when we add all those numbers together, we end up with 4.77 units. We don't have any other specific units, just U for units. Then we do a similar thing for r sub y. R sub y is a sub y plus b sub y plus c sub y. And then I take the values from here, so I add these things up together, and that would be 2 minus, so it's plus negative 1.50 plus 4.83, and those added together will give us 5.33 units. So now I know that vector r, or the magnitude of vector r, I'm going to write it like this, is the square root of rx squared plus ry squared. And that will be, plugging in the numbers, 7.15 units. So this is the magnitude of r. then I also need a direction. So let's call this theta sub A for part A is inverse tangent of r sub y over r sub x. So first let me draw your attention to the fact that the x component and the y component are both positive. So if I were to draw the x component, it would look something like, that's the y component. The y component is this. This is the x component, a little bit shorter. So this is r sub x, this is r sub y. So then the angle that we're finding, this is r, this is angle theta sub A. So it is with respect to the x-axis, and the value that we're obtaining should be a positive value. Now, I don't have room for this whole thing here, so I'm going to delete this. And when I plug in the numbers for theta sub A, I end up with 48.2 degrees. So I will write these things up here where I was looking for them. So R is 7.15 units. Theta sub A is 48.2 degrees. All right, now in part B, I need to find again the x component of s and the y component of s, and then combine them. So s sub x is, okay, what's the equation? A minus b plus c. So that will be a sub x minus b sub x plus c sub x. So a sub x is 3.46 from our table here. B sub x is 2.6, so I have a minus sign in front of that, minus 2.6, plus c sub x, which is negative 1.29. And when I add all these things, I end up with negative 0.43 units. Then S sub y is going to be a sub y minus b sub y plus c sub y. So a sub y is 2.00, b sub y is negative 1.50. So one of the negative signs comes from here, the other negative sign comes from there, so the two negatives will actually add. And then plus c sub y, which is 4.83, and I have that backwards. So 4.83. And when I add these things together, I end up with 8.33 units. So I have the x and y components of s, and now I'm going to make some room here. I'll say that s, magnitude of s, is square root sx squared plus sy squared. And when I plug in the numbers, I end up with 8.34 units. So this is my value for the magnitude of vector s. And then theta sub b is the inverse tangent of the y component, so that is s sub y over s sub x. When you plug in the numbers, you end up with a negative 87.1 degrees. And that's a little bit of a mess, crowded there. Let's move it up here. So b is 8.34 units, and theta sub b is negative 87.1 degrees. All right, what does that negative 87.1 degrees mean? Let's draw, just like we did before, the x and y components of this vector. So the x component is negative, it goes like that. The y component is positive, and it's much larger. So then when I draw the vector, this will be my, my vector s, and this is the angle theta sub b, and it's negative because it's with respect to the negative x-axis, not with a positive x-axis. All right, so let me erase this. That was just a little check, and you should always make that little check. All right, now in part C, the equation we have is for t, so tx is negative a sub x plus b sub x plus c sub x, and negative a sub x is negative 3.46 plus b sub x, which is 2.6, and c sub x is a negative value 1.29. So when I plug in the numbers, I end up with t sub x being equal to negative 2.15 units. Similarly, t sub y is negative a sub y plus b sub y plus c sub y, and that will be negative 2 plus negative 1.5 plus 4.83. And when we add those numbers, we end up with 1.33 units. To solve for t, that's square root of tx squared plus ty squared. And when we plug in the numbers, we end up with 2.53 units. And the angle sub c is going to be inverse tangent of the y component, so that is 1.33 units divided by the x component, which is negative 2.15 units. And you get an angle of negative 31.74 degrees. So I'm going to write that up here. So t is 2.53. And the angle is negative 31.7 degrees. Again, it's negative because the x component, where is the x component? Here, was negative and the y component was positive. So it's very similar to what we had for s. X component here was also negative, y component was positive. So that's why we got a negative sign for the angle. It's with respect to the negative x-axis. So you can go and do 180 minus 87.1 or 180 minus 31.7 to find the angle with respect to the positive x-axis. So you would get an angle like this rather than this angle. So here is the problem. There's a lot of calculation in it, so be extra careful if you try to do it on your own in another attempt.